So yesterday, we started talking about chemical reactions. Right? We covered the first four. Okay? We covered synthesis reactions that result when two elements combine to form a single compound. Okay? We talked about decomposition reactions, where a single compound breaks down into its constituent elements. We talked about combustion reactions and how they are the burning of a hydrocarbon in the presence of oxygen, producing carbon dioxide and water. We also looked at how we balance those combustion reactions and the two rules that we use to do that. And then we got to this. We got to single replacement reactions yesterday, where we were looking at, in a single replacement reaction, we have an element that reacts with an ionic compound. It's always going to be an ionic compound. It'll never be molecular. Okay? And in that reaction, the element replaces the part of the ionic compound that it is like. Since copper is a metal, it will replace the metal in the ionic compound. So essentially, copper and silver will switch places. Silver will be alone, and copper will be with nitrate on the other side. Everybody follow me on that? Okay. Now, when we're looking at writing the chemical reactions, one of the things we also have to be able to do, and we did talk about this yesterday, is make sure that we obey the law of conservation of matter. And that is make sure that we have the same number and kind of each atom on both sides of the arrow. So on the reactants side and on the product side of a chemical reaction. And we call that balancing the reaction. Okay, so let's check and see if this reaction is balanced right now. Right? How many copper atoms do I have here? One. Okay, how many copper atoms do I have over here? One. Okay, how many silver atoms do I have here? Two. Okay, this two says there are two silver nitrate molecules. So that means there's two silvers, and it means there are two nitrates. Okay, so over here, there are two silvers, so that's good. Right? Over here, we just said there are two nitrate ions. Are there two nitrate ions over here? Yes. Okay, that's why we put brackets around it to indicate the whole thing is there twice. Right? Ringing a bell from yesterday. So the last kind of reaction is double replacement. Okay? And in a double replacement reaction, you have two ionic compounds reacting. Okay, so replacement reactions, again, always involve ionic compounds. In a double replacement reaction, two ionic compounds react, okay, and they form two new ionic compounds. Essentially, what happens is the metals switch places. Right? So we can see that on the reactant side, calcium is with chlorine, but on the product side, it's with carbonate. And that's because sodium was with carbonate on the reactant side, and now sodium is with chlorine. Okay, so all that happens is this. Okay, the metals switch partners. Right, and that'll create two new ionic compounds. Okay. With me so far? All right. Is this equation balanced the way it's written? Okay, what's out of balance? Is there something that's out? Okay, let's just walk through it, right? The easiest thing to do is to just walk through it. How many calcium atoms are there right here? One. How many calcium atoms are over here? One. Okay, so calcium's good. How many chlorine atoms are there? Two. How many chlorine atoms over here? Two, right? The two means there's two sodium chloride molecules. All right, how many sodium are there right here? Two. How many over here? Two. Okay, and how many carbonates are there right here? This is carbonate. How many of those are there? One. Okay, in carbonate, there's one carbon and three oxygens, but remember, this is carbonate. Okay, there's one carbonate. Is there one carbonate over here? Okay, then the reaction's balanced. All right, so what you're going to be expected to do here is you're going to have to be able to recognize the reaction types. Okay? There's only 5, and they're all very distinctive. None of them has really anything in common with the others. Okay? And you're going to be expected to be able to recognize them from just the reactants. Okay? And that's fine, because every one of them starts differently. Okay? A synthesis reaction is the only reaction that starts with 2 elements. A double replacement reaction is the only reaction that starts with 2 ionic compounds. Right? A decomposition reaction is the only reaction that has only 1 reactant, okay? 1 compound. A combustion reaction is always going to be CnH2n plus 2. It's always going to be carbon and hydrogen. It's always actually going to be in that ratio. There'll be twice as many hydrogens plus 2 more, okay, than there are carbons. Okay? So it'll always be that plus oxygen. There's no other reaction type that starts with carbon, hydrogen, oxygen. Okay? They're all very distinctive. And a single replacement reaction is the only reaction type that has 1 element and 1 ionic compound as the reactants. That is just something you will have to memorize. Okay? So it's a matter of going over your notes and memorizing the pattern for each of the 5 reaction types, okay? Using just the reactants. Okay, here is what I want us to try. Okay, this is communicating the chemical reactions. This is what we've been talking about all along. We want to write them out. Okay, we don't have to include the states of matter, just the compounds. Okay, the arrow is kind of our equal sign, okay, and then we want to make sure that it is balanced. This one is already balanced. Okay, so here's what I'm going to want you to do. We'll walk through the first one together. I'm going to want you to identify the reaction type, write it out in words, which basically means write the names out. So you're writing a word equation. This is a formula equation. And balance it. Now, we haven't talked about balancing any other type of reaction other than combustion, which had its own rules. Okay, so we're going to look at that with this one. Okay, so I'll give you a second to get that one written down, and then we'll walk through it together. Okay, in this reaction, I have nitrogen reacting with hydrogen. Both of these are elements or compounds? Elements. Okay? So, what reaction type starts with 2 elements as the reactants? Synthesis. Okay, so this is a synthesis reaction. Okay, then I need to write it out in words, which basically just means naming. What's this stuff? Nitrogen. Okay, it's not dinitrogen. Remember, nitrogen's one of our special elements that comes as a pair. That doesn't change how we name it. What's this stuff? Hydrogen. Okay, what's this stuff? Ionic or molecular? It's molecular. They're both nonmetals. How do I name molecular compounds? This would be nitrogen trihydride. Okay, just naming molecular compounds. Hey, do you see now why I was, harping on how important it was to be able to write formulas and names? It's a pretty big part of writing chemical reactions. Sometimes I'll give you the reaction in formula form and ask you to write it in words, like we just did. Sometimes I'll give it to you in words and have you write it in formula form. And if you don't get the formulas right, you won't be able to balance it. Okay, so it breaks down pretty quickly. All right, the last thing I need to do is balance this reaction. So, for the other 4 reaction types, synthesis, decomp, and the 2 replacement reactions, we balance them starting with the largest number. Okay, combustion reactions, we balance those alphabetically, follow the rule of two, they're on their own. Okay, for all other reaction types, we start with the largest number. So what's the largest number in this equation? 3. So on this side, I have 3 hydrogens. On this side, I have 2. How do I balance that? All I can do is add big numbers. Okay, I can't change the little numbers, but I can put in big numbers. What's the lowest common multiple of 2 and 3? 6. Okay, so what would I multiply 3 by to get 6? 2. All right, so I'm going to put a big 2 right here. Now I have 6 hydrogens on this side. What do I need to put in front of this to make 6? 3. Okay. And when I put this 2 here, this 2 also applies to the nitrogen. So now there's 2 nitrogens over here. How many are there over here? 2. Always a good sign. Okay? Always a sign that you've done it right. If when you get to the last thing, it's already balanced because of something you already did. Okay? In this case, that 2 made this work. So that's how we balance. We kind of go back and forth, reactants to products, making sure we have everything balanced out. Okay? And all we can do is add coefficients, the big numbers. Okay? We cannot change the little numbers because those were either given to us or we arrived at them by doing a drop and swap and can't change them. All right, I want you guys to try those 2. Same thing, identify the type, write it out in words, and balance it. people who've done the second one? Okay. Do we need to go over that one? Are we stuck? All right, so if we're looking at our second one here, we've got nitrogen, which is an element, reacting with calcium chloride, which is an ionic compound. Right? What kind of reaction starts with an element reacting with an ionic compound? Single replacement. Okay, so this is a single replacement reaction. Right? That's the first thing we have to write. It's a single replacement reaction. Then I need to write it out in words, which is just naming. This stuff is nitrogen. This stuff is calcium chloride. This stuff is calcium nitrate. Or sorry, not nitrate, nitride. And this is chlorine. Okay, so it's just naming, right? That's nothing new to us. We know how to do that already. Then we got to balance. All right, what's present in the largest number? Yeah, calcium has the biggest number. It's a 3. So I'm going to start balancing that because it's the biggest number. All right, on the product side over here, there are 3 calcium atoms. Over here, there are how many? Just 1. All right, so what do I need to write in front of this compound to make 3? A 3. Okay, because 3 times 1 is 3. All right, so now there's 3 calciums. But when I put that 3 there, it also applies to the chlorine. So now how many chlorines do I have? 6. Okay, so I got to go over here, and what do I need to put in front of this chlorine to make 6? A 3. All right, so now our calcium are balanced, our chlorine are balanced. The only thing left to check is nitrogen, and it's a 2 and a 2, so it's already balanced. Now the whole equation is balanced. Okay, we're done. Right, so we just go back and forth, we balance one thing, and then we balance the thing it's attached to, and then we balance the thing that's attached to. It's back and forth, back and forth, back and forth. All right, we're going to spend lots of time on this. If you're not getting it right now, don't panic. There's time, okay? It just takes practice. Okay, try the next one. You won't balance that one the same way. Ready to go over the third one? All right, so in this one, we have a compound that contains carbon and hydrogen reacting with oxygen gas, and the products are water and carbon dioxide. There's only one reaction that looks like that, and it is combustion. Okay? This is a combustion reaction. If you've ever heard of someone lighting their fart on fire, that's this reaction. CH4 is methane, which is fart gas. Okay? It is flammable, probably not in the concentrations it's present in a fart, but okay, it's an urban legend. So, this stuff is methane, that's its common name, but we would name it as an ionic compound, which would be carbon tetrahydride. It's reacting with oxygen. And it's going to produce water. Water is the only compound you may use the common name for. Okay? Because I have people try all kinds of things. Hydrogen hydroxide, dihydrogen oxide, hydrogen monoxide. It's like just water. Water's good. Okay. And this stuff is carbon dioxide. All right, there are two special balancing rules for combustion reactions, but we are only going to need one of them. Because, how many carbons are there? 1. And 1 not only is the loneliest number, but it's also an odd number. And we only use the second rule when we have even numbers of carbons. All right, so I've got 1 carbon over here. I got to balance alphabetically. That's the rule I got to follow. 1 carbon here and 1 carbon there. So that's a good start. Okay, 4 hydrogens here. How many here? 2. All right, so what needs to go in front of the water? A 2. Okay, when I do that, I now have 2 oxygens here and 2 more here for a total of 4. What needs to go here? A 2. And now it's balanced. Okay. Questions on that one? Don't be afraid to ask here, guys. All right, give those ones a try. Same thing. Reaction type, written in words, balance. Okay, let's have a look at the next one here. Oh, I was recording that whole time. That was clumsy. All right. Okay, so our next one, we've got only one reactant. What's our only reaction type that starts with only one reactant? Simple decomposition. All that can happen to that compound is for it to break down. There's nothing for it to react with. Okay, so this is a decomposition reaction. All right, if I'm writing it out in words, this is going to be a molecular compound, so I'll need prefixes, trinitrogen, disulfide, and that's going to break down into nitrogen and sulfur. Remember that sulfur is our most special of special elements. It comes as an 8, which means I should probably start my balancing with it, because it's the biggest number. So I got 8 over here and 2 over here. How do I make 8 on this side? Multiply by 4. Okay, what's 4 times 3? 12. What times 2 will give me 12? 6. Now balance. Okay, so yeah, you got to do a little bit of math. You got to multiply and divide simple numbers. Okay, nothing terribly taxing for you. How many people have done the next one? Okay, let's have a look at that one too. So on this one, I've got chlorine as an element reacting with sodium iodide, which is an ionic compound. What kind of reaction am I looking at? Nope, starts with S though. Single replacement, yeah. I've got an element reacting with an ionic compound. So that's going to be a single replacement reaction. Now, in this single replacement reaction, my element is a non-metal, which is why it swaps out for iodine, which is the non-metal in this ionic compound. All right, so we've got a single replacement reaction. In words, we have chlorine plus sodium iodide gives us iodine and sodium chloride. Alright, so that's what that would look like written out in words. And now I need to balance it. What should I start with? Do I have a choice? Biggest number is what? 2. And that means I can start with chlorine or iodine. They're both 2s, and it makes no difference which one I start with. Okay? I'm just going to start with chlorine because it's first. Right? There's 2 chlorines over here, and there's only 1 over here. So what needs to go in front of this? 2. All right, when I do that, that gives me 2 sodiums. So I'm going to go back over to the reactant side and make sure I've got 2 sodiums over here. And as soon as I do that, it balances out my iodines, because now I got 2 iodines on both sides, and I'm done. I will give you a couple more minutes to get the last 2 done. I will tell you that the last one is really easy to balance. And I'm going to remember to pause it this time. So for our second to last one here, we've got calcium chloride. So if we're writing it out in words, we might as well do that right now. Calcium chloride, which is an ionic compound, reacting with sodium carbonate, which is also an ionic compound. What kind of reaction starts with 2 ionic compounds? Double replacement. All right, and that's going to form calcium carbonate. And sodium chloride. Okay, and we said that's a double replacement reaction. Okay, next thing we got to do is we've got to balance this thing. So what should I probably start with? What's present in the largest number? 3. Well, the 3 is part of carbonate. So while 3 is the biggest number, remember that there's only 1 carbonate here, right? So it's a bit tricky that way. When you get a polyatomic ion, it can be a bit misleading. Okay? My biggest number in this reaction is actually 2, and it applies to both the sodium and the chlorine. So I'm going to balance those first. All right, I'll start with chlorine just because it's first. There's 2 chlorines on this side. Now there are 2 over here. That 2 balances my sodiums, and everything else is balanced because everything else is a 1. There's 1 carbonate, there's 1 calcium. And the only things that needed balancing were sodium and chlorine, and they ended up together on the product side. All right, for our last one. Why did I say this one's so easy to balance? Because it already is. If there are no little numbers, everything's a 1. Okay? And it makes it really easy to balance it. Okay? There's 1 hydrogen, 1 hydrogen, 1 hydroxide, 1 hydroxide, 1 potassium, 1 potassium, 1 chlorine, 1 chlorine. So it's already balanced. I don't have to write anything in there. Okay? What kind of reaction is it? Somebody said it. Double replacement. Okay, and if I'm writing that one out in words, hydrogen chloride plus potassium hydroxide gives water and potassium hydroxide. Why did I say that was water? Isn't water H2O? Is that still 2 H's and 1 O? It's just the way water is written if you write it like it's an ionic compound. And sometimes we write it that way. It isn't an ionic compound, but sometimes it behaves that way in a chemical reaction. So we kind of write it that way. Sometimes it's easier to track where everything goes. All right, how are we feeling about this? I know it's the first day where we've done this, but okay, this is the kind of stuff we're going to be working on for the next few days. So a question like this, where I would give you the formula equation and ask you to identify, write it out in words and balance, would be somewhere between 3 and 4 marks. Okay, those marks would be 1 mark for the reaction type, 1 mark for balancing it correctly, and either 1 mark for it being written correctly, or 1 mark for the products and 1 mark for the reactants. Okay, so is naming important? Okay, it's super important. It's not as important when we're going from formula to name, but if I give you the word equation and you have to go to here, it's way more important because 1 mistake will cost you 3 marks. Okay, if you don't get the formulas right, you'll lose the mark for the reaction, you'll lose the mark for balancing because you won't get it right. Okay, and so that would be 2 out of the 3 marks. Okay, you could lose a 3rd mark if it was out of 4, okay, if you got both the products and the reactants wrong. Okay, but if you get 1 compound wrong, you definitely won't get the balancing right. Even if you make it work, like you make it balance out for yourself, if you didn't write it right, it doesn't matter whether you balanced it or not. Okay, the equation's not right, the balancing's not right. Okay, so it's really important to be able to write those formulas correctly and do that stuff. Okay, let's have you guys try these 5 here. Same thing that we were doing. Okay, actually, you know what? No. Let's have you try it the other way. Okay, these 5. So we're going from name to formula name. All right, so I give you the word equation. You have to write it in its formula form, identify the type, and balance. We'll do the first one together. All right, so copper 2 nitrates. Is that an ionic compound or a molecular compound? It's ionic. All right, so I follow my ionic rules. I write the metal and its charge, 2+, the non-metal, in this case a polyatomic ion, and its charge, and then I drop and swap. All right, there's my copper 2 nitrate. It's reacting with magnesium. To form magnesium nitrate. Metal, okay, non-metal. All right, drop and swap. Okay, No, I know I did that part fast, but that's just writing formulas. Okay, I haven't done anything that we haven't been doing for weeks already. All right, what kind of reaction am I looking at here?
A single replacement.
It's a single replacement reaction. This is an ionic compound, this is an element. Okay, the only kind of reaction that starts that way. So, single replacement. All right, now I've got to balance it. Done. And this is already balanced. How many coppers here? How many coppers over there? Okay, how many nitrates here? 2. How many nitrates here? Okay, 1 magnesium, it's already balanced. Okay. All right, give the next 4 a try there. I'm giving you the formula for this one just because I don't remember what the prefixes for 12 and 26 are. So you can just write C12H26, okay, as your first reactant there. All right, so for number 7, okay, we've got C12H26 as one of our reactants. And it's reacting with oxygen gas. What kind of reaction is that? Combustion reaction, right? This is a hydrocarbon, right? Anytime we have CHO, okay, it's a combustion reaction. All right, it's producing carbon dioxide and water. Another thing all combustion reactions do. All right, we have special rules for balancing combustion reactions. Sorry, combust. We are to balance alphabetically, and if there is an even number of carbons, I am to start my balancing with what number? A 2. All right, so I got to put a 2 here. All right, I'm going to have some big numbers. That's okay. All right, what's 2 times 12? 24. All right, so I got to put a 24 right here to make sure I have the right number of carbons. Okay, I've got 52 hydrogens, 2 times 26. So I got to go over here and put 26 there. 26 times 2 is 52. And now I've got to look at my oxygens. So I've got 48 oxygens here in the carbon dioxide, 24 times 2, plus another 26 more is 74. Yeah, I think so, 74. Okay, and then 74 over 2 would be 37. That's right, right? It's dangerous when I do math in my head. All right. Everybody with me on that one? I wouldn't give you one that had bigger numbers than that. That's pretty crazy, okay? But it's still same as any other combustion reaction. I've got carbon, hydrogen, and oxygen. It's always carbon dioxide and water on the other side. Balance alphabetically, move 2. Right, these are just things we have to practice so that we get to hang. How many people have done number 8? Right, let's look at that one too then. So on number 8, we have lithium nitride breaks down. Well, as soon as I see the words breaks down, I know this is what reaction type? Simple decomposition. Yep. All right, it's a decomposition reaction. Lithium nitride is the thing that's breaking down. So lithium is a +1. Nitride is a -3. So when I drop and swap, that is my reactant. Li3N. And it's going to break down into nitrogen and lithium. Now, here's where it gets tricky. What do I have to remember about nitrogen here?
Is always a -2. I mean, it has a 2.
It always has a 2. When it's by itself, it's one of those special elements, and here is where that is important. All right, so when you're writing out a reaction in formula form, you have to remember that some elements do that. They're color-coded on your periodic table to help you remember that, but if you don't remember that, you will not get the reaction right, you will not get the balancing right, okay, and it breaks down pretty quickly. So it's really important to remember which elements are our special ones. Okay. All right, now I need to balance this thing. And this is one of the very few reactions where that rule we talked about, balance the biggest number first, fails. Okay? Because if I look at this and say 3 is my biggest number, go over here and write a 3, it doesn't balance my nitrogens. Okay? Just doesn't work. Once in a while that happens. When it does happen, it usually involves nitrogen or oxygen. In this case, it's nitrogen. All right. So that won't work. I'll balance the nitrogens first instead. How many nitrogens over here? 2. What do I put in front of this to make that work? Okay. How many lithiums does that give me now?
6.
And now it's balanced. Okay. So there's the odd time where you're going to have to think outside the box a little bit. Okay. That's one. All right. Give you a couple more minutes on the last 2 there. Okay, let's look at these last two here. And I left the recording again. It's gonna be one of those days. Okay, hydrogen sulfide reacts with calcium hydroxide. So hydrogen sulfide's an ionic compound, H+, sulfide's a -2, drop and swap, we got H2S. Reacts with calcium hydroxide, Ca, 2+, hydroxide, -1, brackets, 2 outside the brackets. Okay, so there are our reactants. What kind of reaction are we looking at? Double replacement, they're both ionic compounds. All right, so what that's going to produce, calcium sulfide, Ca, 2+, sulfur, 2-. All right, that one's good the way it's written. And water. All right, I'm writing water as HOH. Why am I doing that instead of H2O? The reason is, it's way easier for me to balance it if I can trace where everything comes from. Okay, I know this OH here came from here. If I write it as H2O, then I'm tracking hydrogens and oxygens separately, and it's more involved and it's more difficult. Okay, it's much easier to write things as they appeared on the reactant side, write them that way on the product side. It's way easier to track where they come from. All right, what should I try and balance first? Yep, hydrogen or hydroxide. They're both a 2, but hydrogen's first, so let's do that. There's 2 hydrogens here on the reactant side. There's only 1 here. This hydrogen doesn't count because it's part of hydroxide. So I need to put a 2 here. When I do that, that also gives me then 2 hydroxides, of which there are 2 over here. And now I'm done. The rest of the equation is balanced. There's 1 calcium on each side, there's 1 sulfur on each side. Everybody all right with that one? Okay, don't be afraid to speak up if there's something you lost. Okay. This is a double replacement reaction. Yeah. All right, for number 10, this is another one where special elements play a big part. Phosphorus, P, 4. Okay, it's one of those special ones. Comes as a 4 when it's by itself. It's reacting with oxygen. This is one people rarely forget. Everybody writes oxygen as O2, but it's one of our molecular elements, okay, that we have to remember does that. So those 2 things are reacting. What kind of reaction is that? It's synthesis, yeah. There's 2 elements reacting to form a compound, triphosphorus dioxide. Okay, what should I balance first? Phosphorus. Biggest number is 4. I got 4 phosphorus over here. I've got 3 over here. What's the number I can use to balance those? 12, yeah. Okay, so 3 times 4 is 12. What needs to go here? 4. Because 4 times 3 is 12. All right, when I do that, that 4 also applies to my oxygens. 4 times 2 is 8. 4 times 2 is 8. And my reaction is balanced. Okay, questions on those ones? All right, is it a bit different when I'm giving you the word equation and asking you to go back and give me the formulas? Okay, it's kind of a big deal, especially if we don't get the formulas right. All right, try these ones. Okay, they're like the first ones we did. I give you the formulas, you give me the names, reaction type, and balance. Okay, only way we get better at this, guys, is to practice. So, okay, that's what we're taking our opportunity to do right now. Let's look at the first one here. So on the first one, my only reactant is a single compound. What kind of reaction starts that way? Simple decomposition. All right, so this is a decomposition reaction. Okay. And we have here a molecular compound, so we have to use our prefixes, trinitrogen dioxide. Okay, that's going to break down into nitrogen and oxygen. should I balance first? The nitrogen's the biggest number. Okay, there's 3 on this side, 2 on that side. What's my lowest common multiple? 6. All right, so I'm going to put a 2 here. That gives me 6 nitrogens. What needs to go here? Okay, that 2 gives me 4 oxygens. What needs to go here? What needs to go here, guys, to give me 4? 2. Okay, how many people are done number 2? Okay, we're getting faster at this. Good. All right, so on this one here, we've got calcium, which is a metal and is an element in this reaction. It's reacting with, here's one where you have to be careful, iron 3 chloride. Okay, that's one of those ones that needs a Roman numeral. All right, that's going to form iron. When iron is an element, do I need to put a Roman numeral on it? No, because elements don't have charges. We haven't covered this. It's never come up, okay, up until now. But when something is an element, its electrons are all there, okay, because elements have a net charge of 0. So I don't need to put a charge on this one because it's not charged anymore, okay? And that's going to be with calcium chloride. Okay. What kind of reaction am I looking at here? Single replacements. Okay, I've got an element reacting with an ionic compound. And I would say I should probably start with chlorine because it's the biggest number. There's 3 on this side, 2 on that side. Lowest common multiple is 6. 2 times 3 is 6. 3 times 2 is 6. When I put this 2 here, it also applies to the iron. So a 2 has to go here, right? And this 3 also applies to the calcium. So I need to put a 3 over there. All right, give you a few more minutes here, see if we can get the last 3 done and go through them together before class ends. All right, what kind of reaction is the next one with C6H14 plus oxygen?
Combustion.
It's a combustion reaction. This stuff is called hexane because I have no idea what the prefix for 14 is. So we'll just call it by its common name. I would never make you name one where even I didn't know the prefixes. That would hardly be fair. So if it's a combustion reaction, you have to write it out. It'll be something small, or I'll tell you what the name is. Okay? So that is reacting with oxygen. And that's going to produce carbon dioxide and water. Okay, we have an even number of carbons in this combustion reaction. Okay, so I start with a 2. 2 times 6 is 12, so a 12 goes here. 2 times 14 is 28. 14 times 2 is 28. 12 times 2 oxygens is 24, plus 14 more is 38. 19 times 2 is 38. Okay, so we should have that. For number 4, okay, we've got 2 elements reacting to form a compound. So that's a synthesis reaction. Chlorine plus lithium gives us lithium chloride. Right, and we've got 2 here as our biggest number, so a 2 there balances the chlorines, a 2 here is needed to balance the lithiums, and that one's done. Questions on that one? Okay, and then for our last one, we have a double replacement reaction because everything is an ionic compound in this reaction. Okay, this stuff is magnesium fluoride. It's reacting with cobalt 3 nitrate to make magnesium nitrate and cobalt 3 fluoride. Sorry guys, I want to run out of time. Okay, to balance this thing, I would probably start with fluorine. It's a 3 on that side, so 3 times 2 is 6. 2 times 3 is 6. That gives me 2 cobalts, so I go back over here. Now I've got 2 cobalts on both sides, but that gives me 6 nitrates. A 3 here balances my nitrates and my magnesiums, and it's done. Okay? Eventually, you'll be able to do it that fast. It just takes practice. Okay? I will post your quiz at 3:20 today. There will be a couple of naming and a couple of reactions. All right, so make sure you check it out tonight.